Maybe some of you guys by 4 o'clock today won't be able to have like a practice exam fully attempted. However, even though you might not have the practice exam fully attempted, still turn it in because I'm going to give you credit based on what you did. Does that make sense? So if you did A multiple choice, B multiple choice, FRQs, and so some of you right now at the 2018, if you're able to have those fully attempted graded by the end of the day, maybe just do some corrections now, turn it in. That's 2 points because the FRQs are half an exam. Does that make sense? Okay, I didn't clarify that really quickly before we started. Why am I leaving this up here on the board? I erased everything else. Well, I guess I could have erased that. And poor BC, they've been working on that so long. But why did I erase everything else but this? How many big concepts in calculus? 3. Limits. Okay, review everything limits. Derivatives, rates of change of box with respect to box, right? D box, D box. Slope of tangent line, it can be approximated with average rates, aka little baby slopes. Or not baby slopes, sorry. Change in y over change in x slope. I can take a derivative of if they ever ask me for a prime, and then I can think of maybe FTC part 2 and other stuff like that. Derivatives, and then integrals. Definite integral can be found by area exactly if it's geometry approximately with Riemann sums, or it can be a change in antiderivatives going back one, right? And of course, if they're asking for, given some sort of rate, some sort of velocity, some sort of prime, if they want some sort of amount, I'm going to need an initial plus integrations net change. Those are the huge ideas of calculus, right? So if at any point today I feel like I need to refer back to it, I want it still up on the board. And if some of you are like, I'm not studying, well, at least hopefully if you're bored, you're staring at that and it's something and it's sinking in. Okay. I think I had some extra 2018. I'm going to go ahead and, oh, did I not? Oh, I thought I did. Okay, never mind. I was going to pull up the webcam and work through over there. Do you guys have any FRQs on 2018 you want to go to? 6? Anything before 6? 5C? Anything before 5? Still 5? Okay, I'm going to start at 5, go to 6, and if anybody wants me to go anywhere else, go ahead and let me know. But let's start with 5, and I heard B and C. Huh? D. So C and D? Okay. Let me just steal the whole number 5 really quickly. I have no idea if my orientation's on or off, but we'll see in about 2 seconds. We are given the graph of G prime, and then we have an F. Okay, well, that's fun. They're just putting together, and they love showing tons of different representations in one problem. So you have a graph down here about one function's derivative. You have an actual function up here. This is a non-calculator problem. Average rate of change, it's a forever, plug and chug. If worse comes to worse, at least write the formula. What is the slope of the tangent line? You should definitely write, hey, f prime of 3 pi over 2, and figure out how to do it. Find the absolute min. Okay, this was one of the person's questions. So absolute min value of f on the interval. I'm not going to necessarily show all the work super gorgeously, but at least in a way. I'm going to do C that direction. I'm going to do D this direction, okay? So C this direction. Find the absolute min. Hey, this was on your forever final. What are the candidates for absolute extrema? Perfect. Critical numbers and endpoints. So at the end of the day, what I want to do using the correct variables is test 0, test 2 pi, and test any critical numbers in between. Critical numbers, I have to set the derivative equal to 0. Have you guys needed to find the derivative at some point before this? Yes. So someone tell me the correct derivative that you found. F prime of x is equal to. Awkward. Never mind. Second d first. Product rule, right? Plus first d second, which would end up being a minus e to the x sine of x. For letter B, all you had to do was plug in 3 pi over 2, and for the trig, simplify. And then just box it and be done. As long as you have numeric expressions, not trigonometric, but numeric, you'd be fine. But for letter C, we got to set that equal to 0 or dne. Now, dne, there are no denominators that can make it non-existent. There are no like weird other domain problems. So forget the dne. There are no dne's, but there are zeros. And whenever you want to find zeros, you should think F-A-C-T-O-R. Factor. Right? So I'm going to go ahead and set f prime of x equal to. You might or might not remember But haven't we in the 27 essentials and then also in class talked about e to the x and about how we need to watch out for him? What's one scenario where I said you have to watch out about whether or not he dominates? What would we be doing where we have to check about dominating? Degree tests. Degree tests are for limits to infinity or negative infinity, otherwise known as horizontal asymptotes, right? Why is e to the x funny? How strong is he if you're going to positive infinity, or his power is going to positive infinity? Strongest that you'll see. There's factorial growth, which is stronger, but that's BC. But exponential is the strongest growth. He will always dominate, numerator, denominator, wherever he is. Exponential, 2 to the x, 5 to the x, e to the x. Well, who's stronger? 2 to the x or e to the x? If they're both strong, if you ever had to compare them, who's stronger? Why e to the x? Because he's 2.71828. If you're comparing exponentials, it's whoever's exponent is bigger. 10 to the x would be greater than 5 to the x, etc. Anyway, but to infinity, e to the x is super strong. But to negative infinity, he's the weakest of the weak because he's going to 0 and going to 0 real fast. Okay. But I also mentioned in context last week, e to the x is also tricky when finding critical numbers because I'm not going to put it there because it's in my way. Can e to the x, you guys just saw me do the basic graph with my swoop, there he is. Can e to the x ever equal 0? Nope. He's only going to skim it. So do I ever have to worry about solving e to the x equal to 0? No. ln of 0 does not exist. That's not going to make zeros, but what will? When does cosine equal sine? Some of you just need to look at your unit circle tonight. When does cosine equal sine? Pi over 4s. Good. Pi over 4s in the first positive, positive, and the third negative, negative quadrants. I'm going between 0 and 2 pi, so therefore pi over 4 and 1 1/4 calzones, 5 pi over 4. What do we need to do to find the absolute min? Plug it into the original. Good, 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 good. So x equals pi over 4 and 5 pi over 4, just showing our work. If you want to, you could go ahead and do candidates, but in our explanation, because they say justify, that's when I'll talk about, hey, when testing the candidates of critical numbers and endpoints of f, this guy was the lowest, therefore he's the absolute min. Plugging in 0, e to the 0 is 1, cosine of 0 is 1, 1 times 1 is 1. Pi over 4, if you're worried about that math, you guys can totally do e to the 0 cosine of 0, and then just hope that you know what it is and never write it, because you don't want to be wrong. And hope that you guessed the right one. Pi over 4, what the, yeah, it's weird, I don't know, but cosine of pi over 4, that's going to be root 2 over 2. Oops. Sorry. That's pi over 4. 5 pi over 4, e to the 5 pi over 4. Isn't that a bigger number than that one, guys? Ah, but this one is a negative cosine, whereas that was a positive cosine. Well, negative number is lower than a positive number. And then 2 pi, e to the 2 pi, that's even a bigger than that, but cosine of 2 pi is still just 1. Maybe you guys are bad at your unit circle, but if you realized at least this is a positive, a positive, a positive, and a negative, hopefully you would be able to say the absolute min value of f Do you guys see the difference in what I put where? Because what were they actually asking for, the y or the x? Value of f, and f is a y value, right? If you didn't actually show me that, and you could have also plugged in negative root 2 over 2, but if you didn't show that as the min value, you would lose a point, because this is when it happens. This is the at, but they were asking for the of. And my justification would be something to the effect of absolute min value of f is da-da-da, which occurs at da-da-da, since this value was the lowest that occurred Now you state your forever card. Occurred only has, don't worry, they don't take off for spelling. 1 R or 2 R's? 1 R. Occurred when testing the candidates. You can be super snazzy and they'll be impressed. Of endpoints and critical numbers within 0 to 2 pi. It was a closed interval, right? Yeah. Still sticky stuff on my board. Any questions on that one? Cool. So then, Thomas, D. Aha! It's a limit. Perfect. I'm so glad you asked that, because then we can make sure we're showing it correctly for the AP, guys. Let G be a differentiable function such that, that's weird, they gave me the graph of G prime, the derivative of G is shown below. Find the value of the limit as x goes to pi over 2 of f over G, or state that it does not exist. Okay. We've talked about this a little bit, but not a lot. But now is the time to talk about it. The limit as I go to pi over 2 of f of x over g of x. When we go to plug in, we're going to get, I'm just going to tell you now, we're going to get 0 over 0. And here's a dilemma. If you started plugging in, if you're like, okay, this is e to the 0, cosine of 0, she's here, all over, oh wait, pi over 2, sorry. I was like, well, that's not going to be 0 over 0. This is not L'Hopital's. That is so weird. E to the pi over 2. We're in 2018, Rachel. Cosine of pi over 2. All over g of pi over 2. As soon as you put 0 over 0, the AP guys are going to mark you off if you don't do the following. This would even be better. Why? If you put up here, this limit equals 0 over 0, if you put 0 over 0 in your calculator, it does not exist. So when you put equals 0 over 0, if you don't cross it off, you're saying the limit does not exist, and then 2 seconds later, the limit exists. The logic does not follow. And they're going to take off a point for that. So if you realize it's 0 over 0, cross that out, because technically you don't know if the limit does not exist yet. This means keep going, right? So cross out the DNE. They can't grade you off for something you cross out. But then go ahead and say, okay, the limit as x goes to pi over 2 of f of x is 0. The limit as x goes to pi over 2 of g of x is 0. This is a legal way of writing it, because you're like, okay, the top would be 0, the bottom would be 0. Justify your answer, since the limit as x goes to pi over 2 of f of x over g of x is indeterminate. L'Hopital's applies, which implies. And then you can go ahead and do your derivative. So then the limit as x goes to pi over 2 f of x over g of x, since L'Hopital's applies, equals, now it's time to take the derivative of the top and the derivative of the bottom. And since they gave you a graph of g prime, man, we're hoping that g prime of pi over 2 is not 0. Haha, it's not. It's 2. And then f prime we did way up here, so we could go ahead and plug in pi over 2 as well. So that'd be e to the pi over 2 times cosine of pi over 2 minus sine of pi over 2, which would end up equaling, that's going to be 0, that's going to be 1. Sorry guys, they do want you to simplify trig. I should have written negative root 2 over 2. Negative e to the pi over 2 all over 2. Was not 0 over 0, so we're totally allowed to write equals because it does, the limit does equal that value. Technically, L'Hopital's does have one other condition. I believe f and g need to be differentiable, which we just saw they're both differentiable at pi over 2 since we plugged in, but also continuous. But technically, we also showed that because we plugged in. So I think we're good with continuous and differentiable. There were a couple other conditions that have to be true, If you want to double check and make sure that you didn't need to write something about it, f and g being continuous and differentiable functions around or at pi over 2, you can probably, I'm sure someone's done a video on 2018, or you can check out the scoring guidelines. Oh, we have the scoring guidelines. That was number 5. Is there anything else in number 5 that you guys want me to talk about? Let me go look at that L'Hopital's real fast. They do state it. LH for L'Hopital's is totally fine. This is good equals that is good, that is good. This is good, this is good. See, we're good. As long as you cross off that equals 0 over 0. The struggle is, yeah. Nope, this is the one they used at the conference seminar this year. I forgot about it. Because G is differentiable, G is continuous. The reason that you had to include this, F, they gave you a function. You can look at it and say he's continuous, no big deal. You didn't have to state that. It's just part of your math training. Cosine, sine, e to the x, they're all continuous. You didn't have to state that. The problem is G, all you were given was a graph, all you were given was a graph of G prime. So they were like, you don't have G to look at. How do you know he was continuous? Maybe he wasn't continuous. So F, you saw the function. They didn't make you write about how he's continuous and differentiable because you saw him. But G, you don't actually have the function, so they needed you to state because L'Hopital's needs it. Since that limit is indeterminate. And F and G are differentiable and thus continuous. Now guys, in the scheme of things, there are 108 possible points on your AP. Would one point about continuous and differentiable really be something that you kill yourselves over tonight as far as studying and memorizing? No. But if you think about it, L'Hopital's saying continuous and differentiable is a good thing to do. Make sense? Cool. All right, number 6 was our next one, yeah? Okay, let's go check out number 6. What parts did you guys want? Yeah. Why am I glad you said B? Well, who's the most important part of this entire thing? Y. Differential equation, find a particular solution. Where's the chunk of points? Out of any FRQ part, this is at least tied, if not the most, right? But let's go ahead and peek at B and then peek at C. I'm going to need some more room. So let me keep that at the top and let me take a picture of the bottom. And then I'll do the work underneath. Peeking at B, and then if we have time, peeking at C. But if I was to give a name to this, I would call him the differential equation problem. Now, it's been a couple years. But guys, if they use the word, and you can make a note, color pen. If they use let be the. If they say something like let y equals f of x be the particular solution to the given differential equation, and they never use the word find, it's probably an impossible differential equation. So before I go showing this one, which is a possible one, what if they were to give you something like dy dx y is equal to 2x minus y? What would your brains think as soon as you saw that in an FRQ? Oh, I'm going to have to solve it. Move the dx, right? If you start moving the dx, which is exactly what I'm going to want you to do in this one, and something like this happens, how do you divide to only move the y? You don't. They can give you an impossible to solve by hand differential equation. But if they give you an impossible to solve by hand differential equation with x being plus or minus y, the wording will never say find. It'll always say let. And they'll be asking you a question. You see in letter B, you're not supposed to be solving the differential equation yet. They're going to use let y equal f of x be the particular solution. If it says let, you're like, let it be. Okay, fine. I must be able to use it without solving it. But if they say find, now what is it your job to do? And they've given you a possible to solve differential equation. Does that make sense? So there have been years when there's a differential equation problem and it never says find. So you're like, ooh, yeah, I'm going to go get those 5 points, 4 points, 8 points. I'm going to do it. They never ask find, and a kid gets stuck and they end up losing all the points because they thought they were supposed to do this. So if it's an impossible to solve, they're just asking you to use it. So if you see let, like the wording is right up here, you guys can be thinking, this means use, not solve the diffie-q. Okay? When you see let, it means use, not solve. So, Thomas, in answer to your question, when it starts talking about a tangent line, they're not asking you yet to solve the differential equation up above. That's letter C, and that's where the bulk of the points is, but they're asking you to use it, not solve it. Use it how? Let y go up a particular solution to the given differential equation with an initial condition f of 1 equals 0. They gave me a clue. Bless you. Write an equation for the line tangent to the graph at 1. Y minus y1 equals m times x minus x1, yeah? Okay. Let that take us to, we're supposed to be doing it at the x equals 1, therefore the point 1, 0. If some of you need, rewrite that point in a way that makes more sense to your brain. And then you can do y minus 0 equals f prime of 1 times x minus 1. Does that make sense? F prime. They didn't give me f. I can't take a derivative. Ah, they didn't give me f prime of x. Who is f prime of x? The derivative. The differential equation shows me the derivative, right? So therefore I can go ahead and do y minus 0 is equal to x minus 1. It's my job to plug in. So then I can do 1/3 times 1 times 0 minus 2 squared. Guys, this is a numeric expression, so therefore, yes, you can just plug that in and box it and be done. Cool? Cool. Now, letter C. Just because I want to make sure we practice at least one differential equation today. If it is the part of the FRQs, if it's there. That's worth at least the most, if not the most. Sorry, tied with or at least. You guys told me to do what first for letter C? Separate. How? Get rid of division, multiply. And as soon as you multiply, you are allowed to start getting points. Remember, before that, 0 out of 8, 0 out of 5, 0 out of 4. But hold on, wait a minute. Once I multiply, now I see who doesn't belong. Y minus 2. I love this example because it also could confuse some of you guys in the integrating. But let's see if you would have been confused or not. How do I integrate right? Sorry, I should just point. How did I integrate that one? Yeah, I can do 1/3 x squared all over 2. Is that cool? Plus c. I just put the plus c on that side. How do I integrate the left? Yeah, y minus 2 to the negative 2. Can I go ahead and just do my u sub real quick? Careful, if they gave me a 3y minus 2, I'd have some serious issues if I didn't do u sub properly, right? You guys being more careful with your u sub? So I can make this the integral of u to the negative 2 du. At which point, that's not an ln anymore, right, kids? Isn't that a power rule? Of negative 1 over y minus 2 is equal to 1/6 x squared plus c. A few of you guys made a mistake on something similar in your mock AP. Can I just flip and flip? Or do I have to do 1 over the whole thing? Think of it this way. I could multiply this guy by y minus 2. I can multiply this guy by y minus 2. And then wouldn't I have to divide the whole thing? So I'd end up with negative 1 all over 1/6 x squared plus c. Some of you guys did sim illegal. I don't even know what, when you had something similar. The c got stuck. You see him? But the problem is, this is now grouped. So the 1 over, I can't split this up and think of a denominator separately. Now, I could, if you want, I could multiply top and bottom by 6. But if I did that, that would get rid of, but then it'd be 6c. Just be careful. I would tend to be a little bit safer and just leave it and stick it to, well, true stick it to the man fashion. I would then go ahead and add the 2. I would add the 2 on the outside. Oh, wait a minute. Hold on. I'm not done yet until I plug in my clue, right? Anyway, at this point, if you guys don't mind, plug in your clue, get your C, and leave it as messy as you need. Yeah? Leave it as messy as you need. You don't need to make this look pretty. Any other questions on FRQs? Yeah. Yeah. Oh, my bad. I didn't keep reading. Thank you. Yeah. But be careful. When it says approximate, if you put equals, they'll take off a point. And then remember, to approximate a value, you need to get y by itself, which, I mean, technically isn't that bad because you would just add the 0. You would end up with, I would technically write it, Grace, 1/3 times 1 times 0 minus 2 squared times, you plug in 0.7 to your x minus 1. Yeah. And then you would have had this one also with that guy plugged in. Sorry, I ran out of space and just kept on, or stopped looking at the question. That's bad. My batteries are officially dying. Let me change that. And as I do, you guys take one more second to think if there's anywhere else in these FRQs you want me to go. No? Okay. I don't know, hopefully study, maybe pray for night's sleep, right? And if you guys have anything to turn in to me besides LTFs, get it in by 4 o'clock. Put in are definitely already dead.